Bismillahirrahmanirrahim. Assalamu alaikum. Let us begin with our presentation. Myself, Muhammad Husnain, your presenter for today's presentation session. Today's topic of my presentation is Python implementation on the dataset of the production of sugarcane in 600 acres. The main thing is that why I have chosen this dataset. I have taken this dataset because it is related to our family business. This is the production of the sugarcane in 600 acres in the season 2023. It will bring advancement to our work. I want to bring advancement to our work so that we can analyze the statistics of our production in a better way and have a deep insight in our business. As you can see in this slide, these are the 600 different values which are the production of the sugarcane in 600 acres. These all values are expressed in mounds, which is a unit of weight, which is approximately equal to 40 kilogram. This is a frequency distribution table. Here we have a lower class, lower boundary, upper boundary, frequency, and the cumulative frequency. As I have distributed these values into 20 classes, you can see here. Now this is the graphical representation and this is a histogram. It has the frequencies on the y-axis and the classes on the x-axis. Here you can see that the minimum and the smallest frequency is 0 and the highest frequency here is 56, as we can compare it from the level here. It is 56. Now this is a frequency polygon. It is formed by joining the midpoints of the classes and it has the frequencies on the y-axis and the classes on the x-axis. This is a cumulative frequency polygon. Let me clear that a cumulative frequency polygon is of the two types, less than and greater than cumulative frequency polygon. This one is a greater than cumulative frequency polygon. Here we have the cumulative frequencies and these are the classes. This is less than cumulative frequency polygon. Now moving toward the central tendency measures. In central tendency measure we have arithmetic mean, geometric mean, harmonic mean, mode, and the median. Arithmetic mean is basically the average production of sugarcane in an acre, which is 1337.65 mound. Geometric mean is 1323.59 mound and the harmonic mean is 1309.08 mound. Mode is frequently repeated value in the dataset, which is 1571.48 mound. Median is 1381.95 mound, which is the middlemost value of the dataset. From these calculations, we can suggest that the median is higher than the mean, as we have seen earlier, confirming that it is left squared dataset. Mode is 1571.48, which suggests that the frequent occurrence of the higher values in the dataset. Median higher than the mean indicates that most of the acres give more production than the average production. Harmonic mean is 1309.08, which is lower than the median, indicating that the small values present in the dataset are moving the dataset's tendency downward. Geometric mean, lower than the arithmetic mean but higher than the harmonic mean, suggests that the dataset contains moderately large and small. Both values are present in the dataset. Here we have the dispersion measures, which includes Q1, Q2, which is equivalent to quartile 1, quartile 2, deciles, and the percentiles. Here the coefficient of the range is 1.0, coefficient of the interquartile range is 0.13, mean deviation, variance, standard deviation, these all are the deviations, and coefficient of the variance is 18%. Now from here we can conclude that the dataset is moderately spread out, with most of the values falling within a predictable range. All this result is fetched out and this is confirmed by the low coefficient of the interquartile range and the mean deviation. Coefficient of the variance and the variation suggest that the data is fairly consistent and this indicates a stable dataset. Dataset is relatively symmetric around the center. The dataset shows moderate variability and the relative stability. It is well distributed with the majority of the values concentrated in the interquartile range. There are two ways to find out the skewness here. One is Karl-Pearson method and the other is Bowles method. The skewness calculated by the Karl-Pearson method is minus 0.56 and by the Bowles method it is minus 0.268. From skewness by the Karl-Pearson and the Bowles method, we can suggest that the dataset is moderate left skewed, where the mean is less than a median, as we have discussed it earlier. A value of around minus 0.5 suggests that noticeable but not extreme asymmetry in the dataset. Skewness using Bowles method is minus 0.268, which indicates mild left skewed. A value closer to minus 0.2 suggests the data is almost symmetric, but still slightly skewed to the left. Now, moment-based analysis, which may be moment about the mean, moment about the origin. Moment about the mean M1 is always 0 because it is defined in the definition. These are the moments about the mean and the moments about the origin. Beta 1, as we know that it is the coefficient of the skewness, it is minus 0.094, and the beta 2 is coefficient of the kurtosis, which is 1.683. Now we can conclude that M2 is the variance, as we know that, reflecting the dataset spread around the mean. Higher value of M2 indicates the dispersion. The fourth moment is used to compute the curtices. Overall, the squareness is weak, indicating that this distribution is approximately symmetric. The value of beta 2 is less than 3, indicating a Platy-Kurtic distribution. Thank you for listening. If you have any question, then you can ask. Allah Hafiz.